Alright guys, hopefully you can hear me. I just want to do a real quick video, kind of go over what we've been doing in class real quick for your quiz tomorrow. So I got two examples. I got 143 multiplied by 26. We're going to solve that with an area model and a standard algorithm. And then I have that really hard one that we worked today on in class over here. Oh, I just ran line through it. And then that is the 126. And that should be a multiplication sign instead of what was there. So that's going to be a multiplication sign. And that's basically just, we got to find that missing digit, all right? So let me change up, go to my red real quick. So two ways to solve 143 times 26. The first way we can do it is the area model, and we're going to make that rectangle. So we're going to start with a good rectangle. Try not to cut the other problem off. All right, and then we got to divide 143 up into stuff that's easily multiplied. So we could break it into factors of 100, 40, and 3. And then we're going to break 26 into 20 and 6. Now, guys, remember, just because I broke it into 20 and 6 doesn't mean you could have broke it some other crazy way. If it works, it works, all right? That's the biggest thing I want you guys to learn this week about multiplying. There's multiple ways we can get to the right answer, okay? So let's do this first. Once after we set up our area model, then we solve for the 6 partial products. So 2 times 1 is 2 with 3 zeros is 2,000. Okay? 20 times 40, well, 2 times 4 is 8, 2 zeros, 800. 20 times 3, 60. All right? 100 times 6, 600. 6 times 4, 24. Add the 0 from the 40, 240. 6 times 3 is 18. Then what I need to do is I come down a little bit, and then I'm just going to write all these down, my partial product. 2,000 plus 800 plus 60, 2,860. And then I'm going to add my next set of partial products. 600 plus 240 is 840 plus 18 is 858. And then I'm just going to carry everything down. So it's 8. That's 11. So I carry my 1. That becomes 8 and 8 is 16. 17. I carry my 1. So I should have 3,718. And now I want to check to make sure my work is correct, and it's correct, so I go ahead and put my comma, okay? That's one way we could have solved that problem. Another way we could have solved that problem, I'm going to scroll down a little bit, and I'm going to rewrite the problem so we can have it again down here, is, let's change our color too. Another way we could solve the same problem is if I had 143 times 26. I could have split this out two ways. I could have done 143 times 20, and I could do 143 times 6. All right, let me scroll up a little bit. All right, and if I split that apart and I want to solve it that way, all I would basically do is I'd put a placeholder here because I'm multiplying by 20. And then I would do 2 times 3 is 6. 2 times 4 is 8. And then 2. And then over here I would do 6 times 3 is 18. Carry the 1. 6 times 4 is 24. With the 1 is 25. Cross that out. Carry the 2. 6 times 1 is 8. All right, 6 times 1 is 6 plus 2 is 8. And then I would add them together. And if I scroll up a little bit and look at my other work, I can see when I use my area model and when I use my partial product model, look, 2,860, 858. So that just reinforces the concept, hey guys, I can multiply 3 or 4 different ways, and it's always going to work. Last thing we could do, let me change my color again, is if I come over here, and here I'll go rainbow color. I want to see how it looks on the black. So if I come over here and I have the same thing, 143 times 26, and I start multiplying down. 6 times 3 is 18, carry the 1. 6 times 4 is 24. With that is 25. Carry the 2. 6 times 1 plus 2 is 8. All right, then I put my placeholder again. I'm going to encroach on my work. 2 times 3 is 6. 2 times 4 is 8. 2 times 1 is 2. Guys, look at that. 858, my partial products, 2,860. So no matter what I do, I come out with the same answer, my same total. I'm always going to end up at, and so I'm going to go back up here and solve my problem. All right, I only got room, so I'm going to rewrite it down here. So no matter what method I did 143 times 26. I did an area model, which you can see up here. This right here would be my area model where my cursor is right now. I did the standard algorithm, and I also did the standard algorithm, but I split it up into partial products. I used my distributive property. No matter what I did, I came to the same answer, 3,718. Okay? So now we're done with that part, and I want to slide up real quick, trying to keep the video short, and I want to go to the problem we had in class today. So this is very similar to the problem you guys did in class. It will be on your quiz tomorrow. All we have to do is find that missing digit. First, what I'm going to do, I'm going to tell you right now, there's possibility of 2 missing digits. I'm going to give you 1 missing digit. If you write this problem down and bring it tomorrow to me on a notepad, a sheet of paper, and a sticky, and you have the other missing digit, I will give you extra credit. So hopefully you stayed this far in the video. Okay, so real quick, let's figure this out. What do I know about this? The first thing Mr. Savage told me when I'm trying to solve this missing digit problem is I want to rewrite it so I can have room for all my partial products. So let's go with 126 times 2, and I know there's a blank number in there. Draw out my line, and then I know I'm going to erase a little bit further down here to get all this out the way. Let me get my big eraser, or my stroke eraser. There we go. All right, and I'm going to erase most of this. We've already used it. We don't need it again, okay? And then I'm going to come back up here. Let me switch off this color. It's not working too good. Let me go gold. All right. So what I know is that when I add my 2 partial products together, they're going to equal 3,000, but I don't know my missing numbers right now. I just know I have a 3 in the thousands and a 4 in the ones. Well, that means I know that I'm going to have 4 digits here. 1, 2, 3, 4. And I'm going to have 4 digits here because I'm going to have 2 partial products because I have 2 different place values. I have the ones place that we don't know right now, and I have the tens place. Well, remember what we talked about in class, and I'm trying to go super quick. So if you got to pause and rewind and go back, go for it. In class today, we talked about, I know that right here I'm going to have a 0 because when I start multiplying by the 2 in the tens place, I automatically put a placeholder, I put a 0 there. So that means right here I got to have a 4. So I know that 6 times a number is going to equal, let me write it somewhere else actually. That's a bad place to write it. Go back to my pen. So what I know is that 6 times a number equals some number, and it could be 100, it could be in the tens, or it could just be a single digit number, but I know it's going to have a 4. But I also know this is a single digit. So guys, I can literally start with 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is, 6 times 4 is 24. So my answer must be 4. So let's plug 4 in, and now let's work the rest of this out, okay? So 4 times 6 is 24. Carry the 2. 4 times 2 is 8. With the 2 is 10. So I'm going to put a 0, and then I'm going to put my placeholder. I'm going to carry up my 1. 4 times 1 is 4, plus 1 is 5. And then I know I have to go on to the next place, okay? So let's go on to my tens place. I already have my placeholder. 2 times 6 is 12. Carry the 1. 2 times 2 is 4, and 1 is 5. And then I know 2 times 1 is 2. So let's add it together. I have 4, I have 2, I have 10, so I regroup a 1, and that gives me 3. So my final answer for my missing digit was 4. Okay, look at that right there. So remember what I said. I want to say under 10 minutes. I got 10 seconds. If you've solved for the other missing digit, bring it to me on a paper and you will have extra credit. Remember, subscribe, comment. Let me know what you think of the video in class. Tomorrow's Friday. It's going to be an awesome day. All right, see you guys tomorrow.